Intermolecular forces are forces that act between compounds and either hold them together or repel them from one another. Bonds are very organized and form a crystal lattice because of their electrostatic bonds. Solid covalent bonds also form a crystal lattice, but these are weaker because they have weaker bonds between the molecules. So if we were to look at salt and we were to zoom in on salt, we can see that it's very organized, very structured, blue-green, 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 until you make this enormous of blue and green atoms. If we zoom in a little bit more, we see that each blue and green is actually a sodium ion and a chloride ion. And because they have opposite charges, they're going to be pulled together very, very tightly. And when you get this in a three-dimensional structure, this creates an entire cube, an entire lattice of sodium and chlorine. Covalent molecules have very strong forces that hold the individual molecule together, but very weak forces that hold molecules to other molecules. So if you think of it like this, we have a lot of hydrogen and chlorines, and we're going to make HCl, so we're going to take a hydrogen and a chlorine and put them together using needle and thread. Then we're going to take all the other HCls and connect them using Velcro. So now we have a lot of hydrogen and chlorine combined with needle and thread, and then the rest of them are combined with Velcro. When you pull those apart and you apply force, it's where the Velcro is that's going to break off first. So the Velcro is the intermolecular forces that hold covalent molecules together. Dispersion forces are the weakest intermolecular force and occur between nonpolar covalent molecules like this one. So you can see where the electrons are evenly distributed around the chlorines. Dipole-dipole forces result from polar molecules, and this partially positive end is attracted to the partially negative end of the other. So you can see where the electrons make the chlorine part more negative than the hydrogen part. Hydrogen bonds occur between a hydrogen of one polar molecule and either a fluorine, nitrogen, or oxygen atom of another polar molecule. These are the strongest intermolecular forces, and it's one reason why water is so strong. Look at some properties of ionic compounds. The first one is that most are solid at room temperature. They also have relatively high melting and boiling points. They are very hard, rigid, and brittle, and many are soluble in water, but not in nonpolar liquids. And they are poor conductors of heat and electricity as solids, but in their liquid state they are great conductors. Properties of covalent compounds. The first one is that mostly they are gases at room temperatures. They have relatively low melting and boiling points. They are very soft if they're in their solid state at all, and their solubility follows like dissolves like rules. What that means is that polar compounds are going to be dissolved in other polar solvents, but not in nonpolar solvents, and nonpolar compounds are dissolvable or soluble in nonpolar solvents, but not in polar solvents. This is why water and oil do not mix, because one's polar and one's nonpolar. The last property of covalent compounds is that polar molecules are good conductor of heat and electricity, but nonpolar ones are poor conductors. So you have to look at the polarity of the molecule to decide if it's going to be a good conductor or not.
Created using Powtoon.